So welcome to Workflow Design. This is me. You already had the introduction. This is who I work for. I work at Etsy. If you don't know who we are, we're an online marketplace for handmade and vintage goods. But that's the last thing I'm going to say about Etsy because it is entirely relevant to this talk, who I actually work for, because this talk is about all of you. So, brief show of hands. Who's ever heard someone say this? Who immediately followed that up in their own head with this? Right? So what I'm going to try and do in this talk is a little bit about how the first does not preclude the second, and in actual fact how the first of those things, how the fact that there is no correct way to use Chef actually helps you get stuff done in a way that works for you. So to talk a little bit more to begin with about there is no correct way to use Chef. This is Bruce Lee. He invented a martial art called Jeet Kune Do. This is kind of apt given how much Adam talked about Kung Fu this morning. This was not pre-planned. And he said, absorb what is useful, discard what is useless. That was one of the foundational concepts of Jeet Kune Do. This idea that if there are parts of that martial art that you don't like or you don't find useful, just get rid of them. He didn't mind. And what Adam said, if you notice, they're both doing the same Kung Fu hands, so this is totally connected. Adam said, I'm not smart enough to build an ontology that can encompass all the variations in infrastructure. Nobody is. The world moves too fast. And that concept is part of the DNA of Chef, this idea that there is no single canonical way to use Chef. And if you're hoping you were going to come to this talk and I was going to tell you should use Chef this way, you're going to be sorely disappointed. Because there is no magic pill in Chef. There is no one solution that you can take and drop into your organization that will magically fix everything for you. And if you saw me talk last year, you'll have heard me say this then as well. This is because you are the expert in your infrastructure. You're the men and women out there who know your company best and your company's requirements, and you are the people who are going to solve the problems. I can't tell you should use Berkshelf or Spork or Librarian or any of these tools if it doesn't work for your problems. You're the ones who have to decide that for yourself. So on to the sort of second part of the talk, which is how you actually leverage that to drive your own solutions. And when you get to the point of then going out into the community and looking at how to solve your own problems, you'll run into something very common in engineering disciplines, engineering cultures, known as argument culture. And I give full credit to this section of the talk to a developer called Kate Hiddleston, who lives just up the road in San Francisco, who wrote this excellent blog post that goes into far more detail. But what she essentially said was she quoted a linguist called Deborah Tannen, who said, an argument culture urges us to approach the world and the people in it in an adversarial frame of mind. Anyone who's had a discussion on Stack Overflow or Reddit or Twitter or anything involving a tech subject is probably familiar with this concept. Argument cultures are highly useful in a regulated environment like the legal system, where you have judges effectively moderating the discussion to keep it on track. If you've ever seen a televised legal trial, it's very adversarial, with both lawyers going at each other, with a judge in the middle to make sure that everybody stays roughly on track. Engineering is not one of those environments. We don't have a moderator to keep the discussion on track and make sure no one's bashing each other and attacking each other and all this sort of thing. Argument culture is predicated on weeding out weak logic and keeping strong ideas. And it means that everybody is on one side or the other, and we end up attacking somebody else's position and defending our own. And ultimately, we can win or lose arguments just like we can lose battles. Now, in an unregulated environment like engineering, like the industry we all work in, the prevalence of argument culture has a number of damaging side effects. And this is particularly relevant to workflow design because there are a lot of extremely strong opinions about different aspects of this. Argument culture leads to emotional interactions, not rational interactions. If you're approaching a discussion from a point of view where you're firmly convinced you are right and somebody else is wrong, you're injecting emotion into that discussion. It's no longer about talking to the other person and figuring out what the best solution is for them. All you want to do is prove them wrong because you're convinced that you're right. Winning becomes paramount in argument culture. And for a number of reasons, that's extremely unhealthy. Reason number one is that the loud dominate. In argument culture, where essentially what you need to do to be heard is win an argument, the people who are willing to engage in those arguments and have the loudest voices are the ones who end up dominating the discussion. And people may not be able or not be willing to add their opinions into the mix because they're essentially going to be attacked for essentially being on the other side of this war. This means that people are afraid to speak. And often what this results in is best practices actually equate to repeating the loudest arguments that someone's shouting at the time. This sucks for diversity in cultures and organizations. We work in the tech industry, and let's be fair, the prevalent demographic in the tech industry is white men. White men have a lot of privilege that other groups in tech do not have. We can speak our opinions without being attacked for them or without being belittled or demeaned or etc., etc. When we say something, people tend to listen to us. People who don't come from demographics that fit that pattern come into argument culture where the loud voices dominate, and they're already battling uphill because they're not the predominant grouping. But it means it sucks for them trying to engage in discussion and give their ideas and even ask about problems they're having, because if they speak up, they might get shot down and someone will attack what they're thinking. So what I want to do to frame this discussion a little bit more, bearing in mind that we have this tendency to have very combative discussions in tech, is define exactly what I mean when I say workflow. So according to the Cambridge Business English Dictionary, I picked a British dictionary because I'm British and I'm allowed, the dictionary says that a workflow is the way a particular type of work is organized or the order of stages in a particular work process. What a workflow is not, in the context of this talk, is the chef way. There is no such thing as the chef way. Chef is a tool that you use to solve your problems, and there is no one way for you to do that. A workflow is not, we need to use X tool. Whatever tool it is, Berkshelf, Spark, Librarian, Chef DK, any of those tools. A workflow is not telling someone they need to use a specific tool because that may not fit their problem set. It's not saying we need to be more DevOps. It's not saying we need our process to be more like company Y. It's not saying Z in chef is bad, never do Z. And this is something that argument culture particularly plays into. When an opinion on a bad experience you had or a particular weakness of an area of chef becomes the dogmatic statement, Z is bad, never do Z, and people end up repeating that argument. So the way I like to think of it is a workflow is the key to solving a problem. So when I say there is no correct way to use chef, what we do have are lessons that other people have learned in the process of solving their specific problems. So the conversations you have with people about chef are predicated on the fact that other people have had certain problems they've tried to solve with chef, and they've adopted certain tools and practices to solve that problem. And the conversation that's coming out of the other side of their experiences are the lessons they learned in solving their problems. But these lessons may not necessarily match your lessons. So when you're having discussions with people about tooling choices or workflow choices or that kind of stuff, it's vitally important to understand what problem the person you're talking to is trying to solve when they did it. So to that end, we're going to go through a number of case studies here, just to look at some of the motivations that drive different workflows, just to kind of reinforce this point that everybody's trying to solve different problems here. These case studies are all anonymized, and that's for a very good reason. One is because one of the companies involved in the case studies wouldn't let me use their name. The other reason is largely because the companies doing this don't matter. I don't want you to look at the name of this company and think, oh, company X is doing that. That's an excellent workflow. I will copy this. These are all companies of varying sizes. And the way this is going to play out is we're going to look at a quick summary of just a little bit of information about the company, enough to give you a bit of context. Then we're going to look at the company's motivations behind the workflow they ended up with, the problems they were trying to solve. And finally, we're going to look at what they actually do to implement that solution. So on to case study number one. Case study number one is a small internet video company. Their business is video, they're online. They have a very small ops team. They have an ops team you can probably count on one hand, if I'm right. Their infrastructure is mainly based in EC2. It's not on-premise. It's a semi-immutable infrastructure. It uses Packer to build AMI containers, and it uses Chef to run on instances to correct configuration and service status. This was done because every change previously involved rolling a new AMI. So it's kind of mostly immutable, but there's some ongoing Chef maintenance. So what problem was company number one trying to solve when they developed their Chef workflow? These are direct quotes from the people who gave me this information. The first thing they said was they're trying to make it as easy to get started with Chef as possible. They don't want a massive barrier to entry where new starters have to learn, a 6-week training course on how to do the workflow. They want people to be able to ramp up and get started really quickly. They're a small company. They need people to land, hit the ground running and start contributing. The workflow is driven around remote employees, so chats and comments and pull requests are generally the sort of feedback mechanism involved in this workflow. People aren't having face-to-face discussions or sitting around tables and reviewing code. It's largely happening remotely, kind of asynchronously, because everybody's working in different locations. Because this company is small and have limited resources, they aren't interested in letting a third party change stuff unexpectedly in their infrastructure. As anyone on the ops side of the house knows who's ever worked with package management, this is a very real concern when all of a sudden you pull in an update and the world explodes around you. Final motivating factor for case study number 1 was they didn't want to auto-deploy their master branch, the branch containing all their chef cookbooks, because they had an accidental push. This is a good example of iterating from failure, like Adam was talking about earlier. So these are the motivating factors. These are the specific things that this company were trying to solve when they developed their chef workflow. So what did the solution look like? All cookbooks at this company live in a single chef repository. Single chef repository, cookbook per repository, a very controversial discussion. This company chose to do it this way. Dependencies live in a Berks file. This is, again, a fairly common solution you'll find around the place. Pull request development model. Bear in mind all the conversations happening on GitHub. Having the development model on pull requests based into master is a very good way of code reviewing these changes. This is developing for the specific use case of this company. Changes are merged to master, and Jenkins runs FoodCritic and Rubocop. Then once everything's done there, the merge happens into the Jenkins branch, which actually triggers the final upload to the server. Now, nothing about this workflow is particularly unusual. It's using a lot of common pieces of the toolkit. Chef repository, Berks file, Jenkins, FoodCritic, Rubocop. This is using a whole bunch of tools that are extremely common and prevalent in the industry. But they've been combined in a way and are incorporated into a workflow that specifically fits the need of this individual company. So on to case study number 2. Case study number 2 comes from a very different place. They're one project team inside an extremely large company. Their infrastructure is mostly on-premise, but is built using Cloud Stack, so it's still heavily virtualized. Virtual machines are created, then bootstrapped with Chef. They have multiple environments, dev, QA, staging, and production. One problem this company has is they have a large code base of legacy cookbooks being maintained alongside newer cookbooks, which they're developing, with more state-of-the-art cookbook methods, like resources and providers and things like that. But they're maintaining a large legacy code base. Correspondingly, they have one workflow for new cookbooks and one for legacy cookbooks because they didn't want to slow themselves down and be in a position where they weren't able to iterate on the new workflow with the legacy code base. So they're trying to effectively juggle these two problems in one go. So the motivations of company number 2, and again, this was when I essentially asked the people I talked to explain why is your workflow the way it is. So company number 2 said it was too easy to make an innocuous change that broke several features without anybody knowing about it. They had a desire to catch syntax errors or undeclared attributes, which under the old workflow were slipping through and accidentally getting deployed to the server. So they wanted this company's motivation was very much around an existing workflow that was letting a lot of errors slip through and iterating to refine that process. They were looking for complete test coverage of all their cookbooks, mini-test, kitchen CI for validating pull requests, and local cookbook development on individual developer machines. So the motivations here are very different from company number 1. Company number 2 is an established, much, much larger company who's trying to solve specific problems with an older workflow. So what did their solution end up looking like? One monolithic project cookbook. So essentially you have one large cookbook that represents the project. This is a project team, remember. And individual recipes will pull in dependencies and so on and so on. They add dependencies to Berks file and do Berks install. Again, this is in common with company number 1. They'll create their recipes and write tests for them. They'll run kitchen converge until it works. Then they push to Git in the Chef server, test and development, then move on to production. So what we see here is a workflow that, again, uses a number of the same components. We're still dealing with Test Kitchen and Berk Shelf. We're dealing with one cookbook. In this case, it's one cookbook, not just one cookbook repository. But the workflow that was developed was in response to a very, very different problem. And if you took company number one's workflow and tried to shoehorn that into company number two as a best practice, then that wouldn't have solved the problem they were trying to solve. Case study number 3 is a mid-sized online marketplace. Case study number 3 has mainly almost entirely on-premise infrastructure, so they're not using the cloud and most of their infrastructure is not virtualized. Consequently, servers are often long-lived and are not immutable, which adds a whole extra dimension because you have to care much more about the continual state of running servers. Large number of Chef users in both development and operations teams, so we're not dealing with a small expert set of users here making Chef changes. This company has one main environment. They don't split their Chef infrastructure into separate development, production, staging environments. Everything lives in production. So what motivated company number 3's workflow challenges? Number 1 was many chefs. Many people making Chef changes at very frequent intervals. Many of these changes were often made by extremely inexperienced users. In many companies, you'll have a number of very experienced Chef users in the ops team making changes, and consequently, they are able to do a number of things like follow sort of fairly common cookbook design practices, like making everything a resource and a provider and not overusing definitions and things like that. But when you're dealing with a large number of inexperienced users, you can't guarantee that they will always be able to do that or that they'll necessarily know how. This company has a large number of historical cookbooks, which makes using community cookbooks difficult and time-consuming because there are a lot of clashes and dependency mix-ups and things like that. This company actually deploys its main application using a separate deploy tool, so they're using Chef to manage bare metal up to just below the app code, and then they're deploying the app code using a totally separate tool. So again, that affects how they think about Chef. This company is very into continuous delivery, so rather than making, single and frequent changes, they're making rapid iterations, and again, often by inexperienced users. So how did the solution map out for company number 3? Cookbooks live in a monolithic repository at company number 3. Large number of historical cookbooks, not so much use of community cookbooks, so everything lives in an internal repository. They're mostly internal cookbooks. Rules are mapped to attributes for groups of servers, and environments are mapped to version constraints to, bear in mind there's only one environment, to pin everything getting the same cookbook. A major difference with company number 3 compared to the first two is because company number 3 is dealing with mainly on-premise long-lived infrastructure, tooling is geared for efficiency and iteration versus testing. Container-based testing didn't happen to work particularly well in this case because that validates the recipe's work on the containers, where the actual servers are often possibly running 3 different versions of Linux kernel, for example, because they were built at different times. Testing is primarily done instead locally using Chef 0 and yrun, or in production by effectively pulling nodes out of production, testing on real hardware using whitelist to control which nodes get the change. Cookbook versions are always pinned in the production environment, so everything gets the same thing. Now again, company number 3 actually is different in a number of ways from companies number 1 and 2, although they're using a lot of the same tooling, because they're approaching a very different challenge. Company number 3 has a lot more Chef users than the other 2 companies did, and they're dealing with a lot more inexperienced Chef users rather than expert-level chefs. Coupled with long-lived, non-immutable infrastructure, that adds a whole new dynamic to the testing situation that made the eventual solution a lot different. And if you tried switching the workflows of companies number 2 and 3, you would end up with an extremely messy result that would not work particularly well for everyone. Final case study. Mid-sized e-commerce service provider. Again, mainly on-premise infrastructure, so kind of similar to company number 3 here. Multiple product-based teams, however, so you're not dealing with just one team making Chef changes. You have a number of multiple different teams working on different products, all working with the same infrastructure. Correspondingly, there are multiple environments to support these different teams. So case study number 4's motivations were somewhat different, and they were based around this dynamic. Teams are based around the products they build and run. So team structure is based around, if you're on an individual project, that is essentially what you care about most, and your work is geared towards that specific project. Correspondingly, teams had different opinions and requirements for workflows. So even within this company, it wasn't possible to take one single workflow and apply it to every single person, because different teams required different things. There were teams that required far more auditing and regulation, other teams who wanted to iterate extremely rapidly, and it just wasn't possible to shoehorn one workflow into place. Correspondingly, a lot of effort at this company was spent on new greenfield projects because they didn't want to be effectively papering over technical debt they already had. They wanted to start new things that had best practices. Chef was new to most people at this company when they started rolling it out. So coupled with the workflow challenges of having different requirements from different teams, a whole lot of people didn't know Chef, which meant that a few people were kind of bootstrapping this workflow. There was a lot of pressure to produce visible and demonstrable results as well. So when you combine all this, you have pressure from the top down to produce demonstrable results. Chef is new to most people, and a whole bunch of people had very different ideas about how to use Chef. In a way, that kind of encapsulates the community. That's the kind of thing we're all dealing with when we have to look at our Chef workflows. So what did company number 4 come up with to tackle this problem? At the moment, 85% of their cookbooks are in a monolithic repository. However, they are now starting to use community cookbooks and starting to move towards a more repo per cookbook style model, wrapping community cookbooks as they need to pull in their own functionality. When you're dealing with pressure to produce demonstrable results, you may not necessarily even have time to write your own cookbooks. This goes back to there's more than one way to do things in Chef, but a lot of the time we just need to get stuff done. We have pressure on us from above that doesn't give us the luxury of time to spend all the time we'd ideally need on a perfect engineered solution. Team and product-specific environments were introduced to essentially try and give teams maximum amount of flexibility to dictate their workflow based on their own needs. This company used roles typically to set permissions, etc., on different groups of servers because, again, these different project teams have different requirements. You can't just have a one-size-fits-all solution where they're all using the same stuff all the time. Cookbook pinning was made optional in this workflow. Company number 3, I didn't mention specifically, company number 3 rigidly pins cookbook versions with every single change. Company number 4, that didn't actually work that well for them because of these teams having different needs. Some teams that had very strict auditing requirements and so on wanted to pin to strict software versions. Other teams, that just didn't work for them, so they adapted, and this is what they came up with. So these workflows, I intentionally, as I said, I haven't told you which companies these correspond to, although some people are in the audience who know exactly who I'm talking about. And I haven't gone into a great deal of detail on the exact specific, I haven't gone into too much detail on exactly the nuts and bolts of every company, because that would be a lot of separate talks. What I'm trying to demonstrate here is that these 4 companies had very different problems they were trying to solve. They're all relatively, the problem is essentially they want to push out Chef changes, but the actual motivations behind those problems were completely different, and so were the solutions. So when you want to create your own Chef workflow, how do you do that? Bear in mind, as we've seen here, you can come out with wildly different solutions for very different problems. And as we said before, the prevalence of argument culture and technology means you'll often have a number of people, particularly loud voices, advocating specific solutions as the way you should use Chef. So what's someone to do? We're going to cover a bunch of different kind of action points here that are what I'm hoping you'll take away with this for how to come up with your own workflow. Number 1 is to figure out what problem you're solving. Number 2 is to figure out who you're solving the problem for. Number 3 is to have this ideal solution in your head of what you'd eventually like to get towards. Number 4 is choosing your tooling. And number 5 is implementing your workflow. So we're going to step through these a little bit and talk a bit more about each one. Firstly, what problem are you solving? This is the underpinning of any engineering endeavor. It applies just as much to Chef workflows. If you don't know what problem you're trying to solve, you don't know what it is you're trying to implement in the first place. So write down a simple problem statement. This could be something like, I want to automate app deploys. I want to automate server builds. I want us to test our cookbooks more. Have a problem statement that you are trying to solve that is what you can reach for, like Adam was talking about this morning when you define company purpose. With your workflow design, you want to have that statement you can reach for that says, this is what we are all working towards, and people can check their progress against, is it working towards this result? Break that down into simple pieces, especially if it's a more complex problem. It may involve different teams and so on. Break it down into simple, discrete chunks so you can measure your progress against each different stage. Who are you solving it for is a trickier one. Because as engineers, as Jez alluded to this morning, often the reason people become engineers is so they don't have to talk to other people. But it's vitally important when you're designing a workflow to understand your stakeholders and understand your business's priorities. IT operations engineering often function as service-based organizations. In some cases, we aren't the ones driving the product features. In some cases, we are. But in some cases, in many cases, our work is driven by the priorities the business has for us. In operations especially, we don't always get to dictate our own work. The company decides what their priorities are, and our role is to facilitate that. So when you're designing workflows, you have to understand what your stakeholders care about most. To pick a random example, if you're working for a company that experiences a lot of downtime, and you have decided you're going to do a chef workflow that focuses on testing, but what your management really, really care about is the website stops going down so much, which may be for an unrelated reason, you're not serving your business by doing that workflow. You're fulfilling an admittedly admirable engineering objective, but it's not what's most important to your business, and therefore that's not going to make them very happy. How often will your stakeholders work with your solution? It may be your stakeholders are yourself and your team, and essentially you're designing a workflow yourselves. Or it may be the case, so one of the ones we have at Etsy, is we're often designing workflows that are going to be used by other teams, often ones who don't know Chef that well. How often are these people going to have to work with your solution? And is it going to fulfill that requirement? Are they going to be working with it once a day, multiple times a day, once a month, if you do, slower deploy cycles and whatnot? And finally, we have to remember Conway's Law. Conway's Law was coined by Melvin Conway in 1968 and says organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. The way I like to think about that in the context of chef workflows is for example, if you decide to copy Etsy's chef workflow, our chef workflow is based around a company that has very flat organizational structure, lots of inter-team communication, and we deploy changes extremely rapidly. If you work for a company which is dealing with intense audit requirements, possibly you have to be PCI compliant, you have to worry about things like that. Maybe you work in a much more hierarchical infrastructure. If you try to put our workflow in your organization, it's not going to work for you because it doesn't reflect the way your company functions. So often chef workflows have to almost mirror the communication structures of your organizations, because if you're dealing with a hierarchical system with multiple levels of approval, your workflow will often have to reflect that you might need different approval at different steps in the process. Or if you're dealing with an extremely collaborative company, that DevOps, if you will, that's doing DevOps, and you impose a process that includes multiple change control steps, and there has to be sign-off at each stage in the process, that's going to slow people down again. It's not going to mesh with the way the company works. So once you've figured out what you're trying to solve and who you're trying to solve it for, come up with an ideal solution, to have an ideal end goal in mind. You have your statement of purpose of what it is you're trying to solve, but it's also beneficial to just to have in your head a rough idea of, like, if you had all the time and resources in the world, how would you like this to end up? It's something to aspire to. It gives you an aspirational model of something that you would like to work towards. You may not get there initially, but at least you have it as the end goal of maybe you can iterate towards that. Agree this with your stakeholders. Often many people who are designing in the same situation as me, for example, when you're designing workflows, you aren't in management, and you may not necessarily have full insight into whether your stakeholders agree with the thing you're going to do. Jez mentioned this morning about someone in Amazon who did something against the express desire of their VP, and because it worked out and they had data to prove it, didn't get fired. Not all of us have that luxury. So agree with your stakeholders the problem you're trying to solve and what your workflow is the solution your workflow is trying to drive. Your stakeholders are ultimately our stakeholders are the ones who pay our wages in a lot of cases. They're the ones who are responsible for keeping the company making money and so on and so on. And it's important to have agreement at every step of the process. This is the collaborative aspect of DevOps. It applies just as much engineers talking to managers and stakeholders as it does engineers talking to operations and NetSec and other parts of the company like that. Also recognize, even though you're writing down your ideal solution, you're not going to get there in one go. You're not just going to press a button and have this magical workflow pop out the end. You're going to have to iterate a lot, but you will know what you're working towards, which gives you that sense of purpose that Adam is talking about, where you're working towards an objective, and you have this thing that you want to get to fixed in your head, and you can fix it in the head of the other people you're working with. So once we've done all that, we come on to tooling. And this is the part where argument culture tends to play in extremely strongly when you run into the loud voices advocating specific tooling choices as the best way to use Chef. So you have to pick your candidate tools. You have to pick tools that you think or that you've been told or whatever might work for the workflow you're dealing with. Now, this is the point where you have to remember that you're the expert on your infrastructure. If, say, I tell you you should use Knife Spark for this problem, you have to remember I wrote that, so I'm biased in thinking it's quite a good tool, and you may not necessarily be in a place where that's actually going to serve you at all. So you have to bear that in mind, that you're the expert in the problem you're trying to solve. Probe the strengths and weaknesses of your candidate tools. If you have a recommendation to pick on Knife Spark again, since I'm not going to upset myself, if you're probing the strengths and weaknesses of a tool, you have to be aware that just because somebody told you a tool is a good idea might not necessarily make it fit with your workflow. I could list off the top of my head a number of weaknesses with Knife Spark. If you're using a repo per cookbook model with heavy Berkshelf usage, it wasn't designed to solve that problem, and it doesn't do it well. Understand the motivations of the tools you're using. Likewise, Knife Spark was designed to solve a problem Etsy had where we were dealing with a number of people making lots and lots and lots of chef changes. That is the problem we were trying to solve with that tool. It is not a dependency solver. It doesn't do the same thing as Berkshelf does, because when Jamie wrote that, he was trying to solve an extremely different problem than I was when I wrote Spark. So understand the motivations behind the tools and look at how those mesh with the problems you're trying to solve. Understand if the tools are extensible. There will often be a case where you'll take a tool that mostly works, but doesn't quite do the trick. Is the tool you're picking going to be extensible if you need to change it to make it do what you're looking to do? And also, and again, the caveat here being don't just blindly copy what other people are doing, but is anyone else using the tool in the same way? Is there someone you can lean on, a peer in the community, who you can talk to and sound them out about if they were trying to solve a similar problem with the tool, how did they find it? What issues did they run into? Did they find there were certain areas where it didn't work very well, and so on and so on? A further option is possibly even make your own weapons. Sometimes there is just no tool that exists that fits the problem you're trying to solve, and you have to make your own. This is an entirely legitimate approach, and many of the popular workflow tools now started this way. To list two I already mentioned, Knife Spark and Berkshelf, those were both written to solve problems, and there was no tool at the time they were written that did the same job. When Jamie wrote Berkshelf, there was no tool that did quite the level of dependency solving in such a convenient way as Berkshelf does. When I wrote Spark, there was no tool that was actually there to enable us to make multiple chef changes without developers treading all over each other. So in often cases, the tools that you're using were written by someone who was trying to scratch an itch and couldn't find a solution and ended up writing their own tool. But if you do this, be sure you have the time and resources to do it. When you're responsible for maintaining your own tool, all of the things you depend on open source tooling authors for, and in some cases Chef if it's a paid feature, things like when there's a bug, you can report it to somebody else and have them look at it. You're not responsible for building the tool, releasing versions, the entire build process, testing, and so on. There's a higher maintenance burden if you write your own tooling, and you have to be sure that you have the time and resources to actually handle that. A clear mission statement is also vital. As engineers, we have a tendency to aspire towards technically optimal solutions. And what this can often lead to, especially if you're writing your own tooling, is feature creep, where you effectively keep adding more and more and more things to a tool that was only designed to solve one specific task, and you essentially never finish it because you're always adding new things. Have a mission statement of what you're writing the tool to solve, and when you've done it, stop, and then iterate further if you need to. Lastly, we come on to implementation. Once we've identified our tooling and figured out the what, the who, and the how, have realistic expectations. You are not going to drop in this chef workflow and have it work perfectly every time. Failure is a thing that will happen. So start slowly. Start with realistic expectations and take bite-sized pieces and work through those and iterate and move on, and eventually you'll work further and further towards a complete solution. Be aware of what Hallnagel calls efficiency thoroughness trade-offs. This is something we all deal with every day multiple times, which is, as I said, as engineers, we aspire to technically optimal solutions, but the demands of our business don't always make that possible. Sometimes you have a release that has to go out on Monday, so you have to cut some corners and maybe not do something quite as completely as you'd like to, because the business doesn't require that. The business isn't giving you the space to do that. So this is something you will have to deal with, and it's worth bearing in mind when you're implementing your workflow. You will have to make these trade-offs, and it's worth, when that happens, make a note of them. Write down, we had to make this trade-off because we had to rush X for the feature release on this date, but explicitly acknowledge that you've made that trade-off so that later on you can go back and address it. Iterate often. this is the whole basis of continuous delivery and DevOps type workflows. Iterate often and learn from your failures, because they will absolutely, with 100% certainty, happen. Treat failures as a normal part of doing business. Mean time between failures, which is a popular metric for things like hard disk lifespans, is essentially meaningless when it comes to this, because it's measuring the time between something you knew is going to happen anyway. Optimize for, as Adam and Jez talked about this morning, optimize for mean time to recovery, mean time to detection. When an issue does creep into your workflow, optimize for how quickly you can fix it, not trying to avoid the failure at all. Learn from your failures. And eventually you'll iterate and improve, and you'll work towards this ideal picture that you have in your head. That's the mission statement you're working towards. Finally, I want to take a slight tangent and say don't fear the code, which is especially important when you're working with Chef, because a lot of the stuff it does out of the box may not exactly fit what you require it to do. The more you understand the code, the more effective you are. You may not be a professional Ruby developer. I'm not saying you have to go out and basically understand as much about Chef Client as Dan DeLeo, who wrote a lot of it, did. But the more you understand the underpinnings of the tools you're working with, their motivations, how they fit together, if you understand how the tool works, when it breaks, you can figure out why. If you've ever been in a position where you've had to log a ticket on, say, for example, the Chef GitHub to say, I'm seeing this weird error, and somebody's come back and asked you a whole bunch of questions you don't quite understand to try and diagnose the error, it helps you, the more you understand the tools you're working with, it helps you to research known bugs and limitations. When you have a bug, you can see, is somebody else having this bug? You can try and figure out exactly what's causing the bug. And you have to be prepared to report and fix issues with the tools you're using. Especially if you're dealing, and one thing I would like to mention specifically is if you're dealing with open source tooling. If you're dealing with Chef and you pay for Chef, that's an enterprise product. You're paying a company to essentially give you a product and provide support and so on and so on. If you are dealing with open source tooling, which most of the tools you use with Chef like Berkshire and Spark and so on are, remember that those tools are being written by people who are largely doing it in their spare time. They are not getting paid, in most cases, to develop those tools. So be prepared to work with the person you're dealing with to help improve the tool. Help them help you, essentially, to use a kind of management-y buzzword sort of phrase. Be prepared to help them work to fix your issue, but also help them by kind of trying to research what's actually causing the problem. I can't say this enough. The more you understand the tools you're working with, the more effectively you'll be able to use them and adapt them for your use. And in closing, it's okay to try stuff. Like there's sometimes a perception with Chef that because everybody wants to do things the right way, that you have to stick to established practices. And often, I was chatting to some of Chef's technical practice managers. Often what they're told is somebody says, I just want you to look at our workflow and tell me how I should use Chef. That's what I want. I want to just get stuff done. I don't want to have to faff about with all this stuff. I just want you to tell me what I should do. But Chef's technical practice managers are expert in Chef. They can help you figure out your workflow challenges. But at the end of the day, you're the men and women out there who are going to have to actually live with that change. So it's okay for you to try stuff. If they tell you that you should be using, for example, Berkshire, and it turns out that for reasons they didn't know about that doesn't work for you, it's totally fine for you to try stuff, experiment, iterate, improve. And on the note of understanding the code, because I have a captive audience, I'm going to plug a little something I did. This is a book I was trying to write. When I was going through all these problems, I was trying to learn the internals of Chef and how I actually adapt it and make it work for me. There was no book to tell me how all the underpinnings worked. So I kind of tried to write the book I wish I'd had when I was learning that stuff. So if that sounds like something you might be interested in, there's a discount code up there. I happen to know Jennifer Burke from Chef found a box with some of them in and is going to give them away basically to whoever wants them. So if you're lucky, they might still have some on the Chef stand. I don't know if anyone else has got them yet. So on that note, thank you for coming to my talk, and I think hopefully we have a few minutes for questions. Yeah. Oops, yes. That was loud.
No. Microphone, yes. There we go.
So I wanted to add one more thing to back on your piece about what is the, don't fear the code, which is, it also relates to the loudest voices. a lot of times working in open source, people are only coming to you when you have problems, and when they have successes, they're not letting you know. So give this guy a hug for Spork.
That's a very good point, actually. Open source software is sometimes a somewhat thankless task, because often when you deal with people, it's because something is broken. So find the authors of your favorite chef tools around the conference. Fletcher's here, who wrote Test Kitchen. Jamie's here, who wrote Berkshelf. Find them and give them a hug and thank you for the tools they wrote that you use every day and that you hopefully don't hate.
Another question coming from Tony.
Hey, thanks for sharing. I guess my question for the case studies you shared, did any or all of those companies start with a workflow design in mind and then execute and end up with that? Or did they just, is that the outcome of what ended up working for them through trial and error?
So I don't think, if I'm right, I don't think any of those companies knew exactly how their workflow was going to pan out at the end, because in almost all cases, they were the result of iteration. So they had in mind the problem, the motivations they were trying to solve, but they didn't start off saying, okay, I'm going to implement these pieces. One of them, for example, there is the, I think, case study number 1, who had an accidental push of cookbooks to the master branch, which went straight out to the server. So they iterated, and now once the test had passed on master, they merged to a different branch, which is pushed out to the server. So they didn't plan to do that ahead of time. They responded to failure and iterated, and that's what they ended up with. So I don't think you will never, I'm almost certain you will never implement a workflow exactly the way you intended at the start, which will be the way it continues. You'll always make changes and respond to failures and tweak and so on and so on.
I think that's what we have time for, John. Thank you very much. Thank you. Please, everybody, give a round of applause for John.